Yeah, so just let's start with who I am. I'm Kosuke. I'm probably best known as a guy who created Jenkins, but that was at this point what good 10, actually close to 20 years ago. Oh my. So for the last 3 years, I've been working on this new startup called Launchable with Harpreet. And then there, as I mentioned, I've been really interested in, passionate about the developer productivity. That is, how to make the developers go faster. And then it's really all about going through these DevOps loops faster. I'm sure you have seen this before, right? And so when I look at now, if I go to conferences and let vendors and people presenting there talk about how they're doing it, they'll tell you a lot shinier story, and then make everyone feel like, oh, like my own team is such a crap. But when I go to their teams, like different teams, and then like I hear what's going on, often what's happening is this, like it's quite lopsided in one part, which is that it's the testing, or more broadly, the spewing out changes is easy, but building enough confidence to that change to the point that you're willing to put in the production or shipping it, that's often the hard part. It's just that this is not particularly sexy, so people don't talk about it. But this is a real challenge. It shows up in so many different facets. My observation is that this is a part that can be like improved on. So today I wanted to kind of double click on this and then see what's going on, and then see what different teams around the world are doing to cope with it. And then so my hope is that if you are having challenges in this area, you might be able to learn some tips and tricks from the like-minded teams elsewhere in the world, or you might be willing to share to me the cool things that you're doing to address it. So my story since I was talking about the DevOps loop, my story starts with you're running a test. Okay, so great. You probably have some automated tests who are running and those are running at some frequency. So you run those, and then now you have the test results. Okay, then what? Right. So that's what I'm calling. So it's only the starting point for a whole wave of activities, and that's what I'm calling the triage. And I'm calling that challenge the triage problems. Now, different products, different tests. So they create different. They have different traits and characteristics. So they stress different parts of the triaging activities. But I think these are the key ingredients, and I'll go through them one by one. But it starts with how you run the tests, and then you need to filter away the noise from the test results to focus on what you want to look into. Then you need to look into the failures to figure out what the nature of the problem is. Then that determines like whose awareness you need to raise, and then the person works on the fix, and then you need to track until the fix shows up and getting verified. So that's the scheme. Now, in some domain, like this really isn't much of a problem. I used to work on a compiler, which is a very deterministic software and no flakiness. So much of this was super easy, at least super simple. And then I talked to people who are doing, like I say, video games or the financial software or more complicated domains in which, the running test, having noise, there could be a lot more challenges. Unit test, it might be obvious, like, whose problem it is. With integration tests, finding out which component blew up is by itself a major deal. So that's what I mean by different parts getting stressed at different places. But what's common in all of those is that these problems build up over time, right? Like when the project is young, and then like another lot of people are working on it, it's easier. But as your project gets successful, bigger, the code base starts to accumulate, so are the test cases, and the more people get assigned, the components start to diverge, they start to develop different ways of doing things, and the test keeps accumulating. And then like slowly but steadily, these things slow down the pace of the progress. Test gets only like a more progressively more flakier, and then at some point it starts to crumble under its own weight. And then there suddenly like you're faced with a crisis of the loss of confidence to the automated tests. So that's the risk of keeping this problem like unchecked, right? So let's look at some of these things one by one, and then I will discuss what the people are doing. So the first is like, okay, so how to get the test run? Now the world is so much simpler if if your tests run quickly, if you don't have too many of them, but they cover they cover a good part of the product. Um, and yeah, but in reality, it's not like that, right? So you can't, most of the projects that have some maturity, you can't test every change in isolation with every test. So you have to be smart about it, like how to run them, figure out the right frequencies and stuff to run. So often these challenges show up in time as, okay, like our tests are too big and too slow, that our tests are not running frequently enough, or that my test capacity is limited, and so the test becomes unstable, or like I can't go any faster, etc. So I think the really like the key solutions that I see employed across the board here, and this isn't a particular rocket science, is to prioritize tests. It's to recognize that not every test is equally important or meaningful or valuable. But so for example, like I'm sure some of you have the concept of smoke tests. Right? Those are like hand-picked tests from the larger test suite designed to run very quickly. That give you some sense of if the project is dead on arrival. Right? I see large teams often make sure that the smoke tests pass before taking on the bigger test executions, because if the build doesn't even pass the smoke test, it's considered dead on arrival. A little more sophisticated approach is, for example, the one that the Google advocates, which is to simply mark the tests from small, medium to large, depending on the duration. That's it. Like they don't even, well, they have a peculiar build system and test system that enables this, but they don't even particularly segregate between integration tests versus unit tests. It's simply the size, the duration of the tests. And then so they could say, from that, they would say, well, early in the development process, we only run the small tests. Or later, and then you might run the medium test every week, and then so on and so forth. So I think one person is reporting that anything being, the screen is blank, but I guess since only one person is complaining it, I assume the screen sharing is working okay.
I can see the screen.
Yeah,
actually.
great. Thank you. So yeah, so that's prioritizing tests. Now, another form of prioritizing the test is excluding flaky tests. And I know this is a controversial topic, but I often see teams deprioritize in this case, flaky tests, especially from the left-hand side of the development, like a pre-merge, because it adds more noise than it helps. So there it is. So the prioritizing test, I think that is a key way to sort of focus on the meaningful test to run. Now, if you prioritize the tests, then you can run those tests at different frequencies. So that is what I call the multi-stage testing. Again, in a larger team, this is very common, but there's usually a transition, like a shift in the development mode. Earlier on, you can afford to run every test on every commit, but then at some point it becomes like infeasible. So you have to have a different test execution cycle, like every night. And then these things are run. So you start to run the same test suite, it's different subset at the different points in the delivery pipeline. Yeah, so that's another one. Now, the other mode that I often see, I don't know if there's a good name for it, but I'm calling here the test impact analysis. And this is the idea that, okay, let's assess what tests need to be run based on what has changed. So I once visited this large, the control software for transportation systems. They have huge inventory of tests, and most of these tests are really simulations, right? So they put the train into the simulated environment, and then put some scenarios, and then make sure that the control system behave the way it's supposed to. So those are super expensive. So they can't afford to run all the tests, even during all the tests. That would take easily weeks. So what they do for the end of the release cycle is, so they identify these are the bugs that we had fixed last week. And then so the QA people and developers, engineering head would come together and say, okay, then let's run these subset because we think those are the tests that might be impacted by the behavior change of the code. So that's been, I'm sure some of you have been in an environment like that. So that's been traditionally done manually, but here one of the things that Launchable has been doing for the past few years is to use the power of the AI or the machine learning to make that automatic. So this is one of the products that we have today functioning in production, where we make our AI estimate, okay, based on what changes, we think the probability of this test impacted is high versus low. And then if you can make a reasonable guess at that, then you can just choose to run the tests that are highly impacted. Therefore, with a much smaller amount of time of execution, you get a good coverage. You get to find all the regressions or more of the regressions that you need. So I think that it still remains as a valid concept and practice, though the particular way it gets implemented might be changing over time. Okay, so another one of I think the common mitigation for the test execution challenge is to address these challenges in provisioning the test environment. So if you're thinking, let's say if you're developing a web app, often you might have a staging environment or a dev environment, but if you can, if you have multiple environments, then you can use those to run different tests independently. Together, and then so that is a capacity problem. Now, when usually you start to have multiple test environments, you have to be deploying techniques like infrastructure as a code, and that is an added burden. But so it's not always readily doable, but it's often worth doing. And then in some sophisticated teams, they can dynamically provision test environment on the fly. So if you're on the cloud, and then if you're at a much higher level of automation, you could do this, and that gives a whole bunch more flexibility. And I often see I often see people develop an in-house test environment provisioning system. So they might have a static number, say 5 different test environments, somewhat semi-automatically curated, or that might be dynamic. And they have it's a bit like a conference room reservation system. Which team is using which environment for which duration for the purpose of testing their stuff, and then so they can hand out stuff like that. And that is not a perfect but a pretty effective way of easing the capacity concerns. At least that way you get to throw more money at the program. So that's about the getting tests to run programs. And then so I want to move on to the filtering away the noise. So most of the time, well, at some point, right? So imagine you have a lot more, a lot of test cases, and then they're fading also enough that they start to overwhelm the humans. It's I guess what we call the firehose, right? And then this is a real challenge because if you have of all this a firehose information, we know not every one of those is a meaningful signal. The prime example being the flakiness. And then this is a real risk because when too much noise comes out of automated test systems, it really starts to erode and eventually destroy the confidence to the automated QA effort. Developers start to basically disregard the entire test suite and its results because they don't trust it enough. This happened, one time in the Jenkins project itself. We developed one time this what we call the integration acceptance test funnels, which is basically testing the whole Jenkins with a whole bunch of plugins as from the user interaction perspective, the user clicking the buttons and doing some things, and then the system behaving as expected. But this was flaky. It also took a long time, and it wasn't well attended enough. So people started just ignoring that outcome, and then so that was unfortunate because we did invest a lot of time in it. And I've seen a similar story, at least on people a test it on the verge of getting ignored in multiple teams. So so here we are talking problems okay, the flaky test fading left and right, and then making it harder for creating crying wolf effect, masking the real problem. Another kind of the problem is the tests, if in places where test failure is identified, but it takes time for the fix to propagate through the integration chains and back again into the place of the test, then until the fix arrives, the test keeps failing. And then so it creates unnecessary noise because it's already looked into, figured out, etc. The third problem that happens is when you have enough of these firehose, often a single regression causes multiple errors. And then so if independent people look at those things, they independently get to the conclusion that they are working on the same issue. And then so they duplicate the work. And that often happens in a large system as well. So what are people doing here to deal with it? So one of the things I think that is the primary topic, I think, is the flakiness. And then there are a few different ways people are dealing with it. So the one is what I think as knocking back or beating back the flakiness, because it's like the weeds that keeps growing in your backyard, isn't it? Like, you can't really eliminate it. In most domains, I should say, like as I mentioned, if I was working in a compiler there, eliminating flakiness was entirely possible and in fact very easy. So no reason not to do it. If you're dealing with more complex systems, like a real-time system, like a control mechanisms, it's much, much harder, next to impossible. So really, like multiple respected engineering team have said, don't try to like eliminate the flakiness because it's a diminishing return, it's a pointless effort. Focus your effort on the most flaky failures and then like knock them back. And in that way, you can keep that in check. Right? So that's one thing people have done, knocking back flakiness. Another common way to deal with flakiness was either to exclude the flakiness, just like, stop creating those noise at the loss of potentially some signals, or use the retries so that the flakiness to some extent gets masked, but you still get to run the test. And then that has a downside of a longer test execution time, but those are relatively easy things. And then the third that I've seen, like the third pattern that I've seen in some places is like you run the flaky test once, but like you ignore that the flaky failure actually happened. So from the purpose of like you exclude those test results from the purpose of CI turning green or red. I thought that was a little extreme, but in this way they're trying to balance the fact that they are running the test, but they are not like getting the noise. They are not letting the noise get in the way of smooth integrations, and so on. So it made some sense. So there's a lot of effort done in this space just to show how serious the flakiness test is, how serious the flaky problem is. Here at Launchable, like we do compute the flakiness for people's test suites, and we can show them. This one is what I consider probably like a state-of-the-art project, which is from, as you can see, the GitHub. They're trying to quantify the impact of flaky tests. So in this particular test, they are saying, well, it's got the impact score of like 1033. I don't know what the impact score actually precisely means, but you can imagine what they're trying to do with it is to drive the attention to the most impactful flakiness and ignore the rest. And then they have some, like analysis about when this flakiness started happening, what are the relevant changes in the code and the test and stuff like that. So trying to create the directly responsible individual, which is another key concept we are designing the process. Here's another kind of state of art from the Dropbox. So the way they decided to deal with the noise from the system is like not let humans see this noisy outcome. They have a system sitting in between. Where the moment the test started failing, this test is put into this noisy test basket. And then even before the humans see them, they start rerunning the tests a few times. They go back to the previous commit and then rerun the same test and then see if they can observe the flaky behavior or see if it's consistently showing the failure. And then, if the test is determined to be flaky, it just gets tossed into this quarantine basket. And then I'd imagine the developers like looking at this basket from time to time at the lower priority to deal with flakiness. But the test in the flaky quarantine bucket wouldn't impact the smooth execution of the CI. Or if in this process it's a change which is determined to be problematic because they're testing the previous binary, then the change automatically gets yanked out from the system. So again, this was not to stop the orderly flow of the changes, orderly flow of the delivery. And then the developer is asked to look at this problematic change at their own pace. So, this is almost like a machine, a system sitting in between the humans and the test results so that it's shielding the noise, humans away from the noise. Most teams I know, I meet in the real world, do not have cycles to build something like this in their, on their own. But hey, this is Dropbox, right? So they can probably afford to do it. So one of the missions that I'm finding, like in Advanceable, is to try to democratize a system like this that most teams cannot develop in-house, but we should be able to, create that and make it readily usable for everyone. Just like Jenkins, the CI system used to be something that extreme engineering teams build on their own before it gets democratized. It's really available software. Okay. So another sort of common techniques to filter away the noise to deal with this noise problem is just snoozing the failures, meaning just say, okay, I acknowledge that this failure happened, and then until something gets done, you just simply exclude them. So I've seen this commonly done by annotating the test by basically like an ignore flag, but with a reference to the ticket, so that later we can see like why this test was snoozed, like while this ticket was in progress. And then if that ticket resolved in one way or the other, then now we know that it's safe to it's safe to re-enable them back again. Or if the fix was to verify, that test needs to be re-enabled once again. So that's in that way they can stop wasting people's attention on these failures that already understood. There's no use in keeping the test failing if that's not producing any more useful information. So yeah, another relatively like a process-oriented techniques that I've seen people deploy quite successfully. So, okay, so now we run the test and then we filter down the nodes so that the only failures that are in front of us are the one that we think are relevant. So the next step is, okay, so what are we now need to actually look at these failures and understand them and what's going on. So I do think, there's a lot of facets to this. As a developer, I'm sure you have experience doing some of these things. Okay, so is this a problem in the application code, or is it that the test needs to be updated to keep up with the app change? Or sometimes it's an environment problem, in which case it's neither. You often want to see like what changed recently. Like that's often the first thing that people try to use to pin down the a possibility of the problem. Okay, or I'm looking at the payment system errors. And then if I see that the payment system did change recently, then I probably suspect that might be related, and so on and so forth. In larger systems, getting more details could be really tricky, because often these tests, like integration tests, the SIT or user acceptance test, treat the system as a black box. So, you press a button, lots of things happen behind this, like a smooth surface of the machines, then something blows up. But for you to see what blew up, you have to open up the bonnet. Another often things that often happens, I do this all the time, is like, okay, it's failing in this way. I don't understand this. Like, did something like this happen before? Like how many times have any of you wished the search in Jira would have been better? Because I know in one of these 40,000 test tickets that have filed and resolved in the past, I've seen this before. I just don't know which ticket it is. Or often these tests, I get handed over this problem from QA people, but I can't readily reproduce a program on my desktop, and then so I can't see how it's hard for me to try to fix it. So there's a lot of facets of problem like that. And I feel like this is the real drag, a race in the mud, and a lot of people are struggling, or at least spending a lot of time. But maybe it's just me, but also at the same time, in some weird way, this is also crazy fun, because it feels like at times it feels like a real detective work. And then there's a science in this, a debugging and troubleshooting, right? You form a hypothesis, you try to find evidence that one way supports that the hypothesis or dispute them, and those discoveries would help you eventually pin down the thing. And then when your guess is correct, it's just it creates this adrenaline dash, at least in my head. And I know some people I talk to are like that, right? But this also takes a lot of contextual knowledge, like people who enjoy or people who are getting relied on to do these things are senior people in the team. And as I feel like their expertise and their time is extra precious. So this is one area I'm really wondering how people are dealing with this to make this more efficient. Because as I said, like often you need to open up the black box. Like driving a car is easy, but if it doesn't go, and you open up the bonnet and then you look at this, like the wires and tubes and pipes going everywhere. And I'm like, I don't know how to do this. I need a professional here. But this often is precisely how it feels when you're dealing with a large system troubleshooting. Or you have to collect logs from the system and you need to look at this number. And then like some expert people would say, oh, that 100 there, that looks odd. And I'm like, I have no idea. Like how did you even know? So there are some like automatic tool assistants, like I know the distributed code tracing tools like Zipkin or Jaeger, like these things help address this, put together the cohesive picture of what happened. But I haven't really come across as many teams who have deployed these things at a large scale. I feel like in most of places people are, SSH into the system, retrieving the logs, and then fill the screen with these different log files and look at that intensely, trying to line up the timestamp from here to there, and then try to guess things. That seems like pretty like a normal, the thing that the teams are doing. But so what are the successful practices here? So I do think that one mechanism is like, this is rather low tech, but often this mitigation I've talked about is low tech, right? But the journaling, I think, is a key mechanism. So the idea is like, if you remember the science experiment class from the college, like this is what they tell you to do, is to kind of record every step of your hypothesis forming, what you have done, what you have seen, how you react to it, and then kind of keep capturing those, like jot down those notes as you go through. So one of the things I recommend, I'm telling my own engineering team is when you're doing this investigation, you take a journal. And that, sometimes it helps me as a primary investigator, like to avoid going through the loops, especially in the complex investigations. And then some other times I can look at another person's investigation journal and then see, oh, this is what this person is looking at when you're facing these problems. So you can learn from these things. And then this journal accumulated over time forms this knowledge base that the newer people in the team can use to see what has happened in the past when something like this has been seen before, what to look at, where things look similar and diverge, and so on. Another practice I love to see someone try and report back is the idea of pairing, right? So in the programming, you have this idea of pair programming between two people at a different skill level as a mechanism of knowledge transfer in both ways. I do feel like this QA investigation work could benefit from the same scheme, but I haven't yet come across anyone doing it, which means maybe I'm wrong, or maybe I'm on the brilliant idea that the world needs to discover. I don't know which is which. Okay, so another common mitigation for this analyzing the problem challenge is to work on the failure reproducibility. The devs often have a real hard time reproducing test failures on their environments. And this is like often not obvious to people who are involved in the QA, who is in it day in, day out, or who has a dedicated test environment, so they don't see that as a problem. But this inability to reproduce the problem close to where they could examine is a real progress. It hurts the progress real bad. So I know some teams invest successfully in this, containerizing the test execution so that you can have like a micro scale environment, close enough environment to be able to attach the debugger, etc. Another common practice I've seen is like keep the test environment around for a while until that investigation happens. So usually, like at least when in some test environment, like instead of recycling the test environment at the end of the test execution, create some time window, like so many hours, 48 hours or whatever, in which you allow the developers who are investigating the problem to log in and examine the actual system. It's like, preserving the crime scene, and then let detectives come back and, pick up the blood residue from the wall, or I guess they're QA equivalent of that. So that I know is pretty effective. So those are the things that I've seen done in this space. All right, so further moving on. So now, you have run the test, filtered down the noise, you looked at some of the test failures, and they figured out why, what caused this problem. So the next step is to, pass that information back to the people who can work on the fix. As I mentioned earlier, in some tests, in some products, this is not a problem. Like if this test is running a pre-merge, then automatically the person who created the pull request is the usual, the first responder. And then the problem might get routed to, let's say, CI guys if they determine that, this is the environment problem, not my change problem. But in larger teams, this is often a real struggle. Because if you do it wrong, this is where the ball drops, right? The QA team did analysis and then passed the ball, expecting the devs to work on. But if they didn't receive the ball, it just kind of drops on the floor, and then it takes multiple days before people notice that, this ball drop happened. And I imagine this happening close to the release or deployment date, and things get really stressful. So what are people doing that? I think the most common mode to deal with is the low-tech solution of the good old triage meeting. I'm sure some of you were in this meeting where the heads of the QA, at least heads of the devs, and then I'm sorry, not just the heads, but the people involved would show up and look at the last test, the analyzed test result, and the QA people would go through like individual one of those, and then like the developers are supposed to either accept or write those to the right team, or they went through the failures that are still active and the whose failure is tracked meetings. I have been at some where I used to work. This was called bug swat, and it was happening, I think, at least like every once a week. Toward the end of the release, it becomes like every day. And sometimes like they argue for like endlessly about, this is not important, or this is important. So that's the starting point. To me, it's a lower bar. Question in my mind is like, how can we do better than that? Because that meeting is like consumes so many important people so much time. So I think a number of experienced QA leaders told me that the key to address this is to agree with the priority. Like which one of you have been in these yak shaving conversations where people would argue for 20 minutes this particular test failure should be P1 or P3. So the key to avoid those things is to come up with this prioritization matrix beforehand. So even though it says matrix, my understanding of this is it's more like loose decision trees. So you might say, failures around the core user journeys, and the product managers often have those identified, or P1. But if they are not around the core user journeys, they get P2 or less. Or you might say, the UI glitch is P3. Start with P3 unless it's affecting more than 50% of the user base, in which case it gets higher. But the information leak is automatic P1, and so on and so forth. Because much of how the response that happens afterward solely depends on the priority. Having a predefined scheme, like even if it's not rigorous, to assign the priority has a huge impact in streamlining the process. So the other thing that I think the people have used successfully is to have a clearer handover process. So again, this is usually a problem with a large team with lots of components with sub-teams, basically. So what I've seen is every component teams of the developers are responsible for maintaining their preferred communication mechanism, to the handover mechanism to receive different issues by different priorities. So they might say, okay, the P3 issues are supposed to be the one, that gets fixed by the next release. So that they go to the issue tracker with this component or this flag. If it's P1, like please notify this Slack channel because that's faster, etc. Now, ideally, at least in the ideal world of the QA people, like they have a uniform handover mechanism across the team, but I have never come across any organization in which QA team managed to dictate to this, tens of developer teams about the uniform handover process. So the best, I think, the practical best they can hope for is to make each team responsible for stating clearly how they want to get fast. So this is a much more practical and a convenient way to avoid the ball drops. And again, things like this, it's only possible with the prioritization. So the Mike has observed that, it's the ticket priority level for him is simply high, medium, low. Yeah, like a red, yellow, green, that's great. And I think that's what I've seen at the workplaces I was involved. I had a P1, P2, P3, I think down to P4 or something. But, it's a nomenclature. It might be slightly different, but you get the idea. I think the point is that the team can agree that these 3 or 4 different priorities exist. So great to hear that, Mike, you're already doing that. Okay, so now we got to the point where the analyzed test got passed to the right people, often gets rewritten, which is a whole different story. Like, one guy saying, "Oh, you made it my problem, but I think this is not my problem." This gets handed back, and then so on and so forth. But the last bit is the test needs to know when the fix is supposed to arrive, right? Because I mentioned some earlier techniques, like you should snooze the failure until the fix arrives. So the consequence of that is, okay, when is it supposed to be passing? Because if it's not, then that means the fix has failed. So the developer would also want to know that right away, and they need to work on it, right? So this, in my mind, it's pretty clear. Well, I used to, my first large environment did this. So to me, this was like how everybody was doing it, but then later discovered it's not like, I've seen plenty of teams who doesn't do this. So I thought it's worth mentioning is that the baking you should bake the commit hash into the build artifact, right? So in other words, create an unambiguous traceability back from the software into the source code that has built it. Often, sometimes you have to come up with the scheme. For example, I used to work for JavaSoft, so they are the manifest file was a good place to put in this shallow commit hash. In Microsoft environment, you have assembly info to do this, and so on and so forth. So this is often the first step of reproducibility. If you're talking about the web app, you should be able to see exactly which version, the client of your web app should be able to request and see exactly which commit, because on that way, the test that's running can know what version of the app is being tested and so on. So it takes a little bit of work to get that in. Usually it's not that hard. And then it pays you back in so many ways that in my mind, it's one of the no-brainer techniques. And similarly, we should all be referencing tickets in the commit logs, or at least in the PRs, and so on. And that also creates this traceability. You could see, okay, this was supposed to be the fix for that ticket. And then if it's nicely squashed, for example, you could also tell that this single commit represents the sole fix. That makes another traceability easier. So between, if you have this a build artifact, baking the commit hash, and then a commit graph capturing information about the tickets, well, you can connect those 2 dots to create a fairly robust traceability into the system. And then so if you have this kind of infrastructure, at least in the teams that have this kind of infrastructure, I saw them people writing a script to compute what has changed from the last time, and then capture that as a part of the CI information. That aids the people troubleshooting issues. That could form a basis for the test impact analysis that I mentioned earlier. That could be used in so many different ways. So those are, I think, commonly deployed techniques that are successful. across the board. So that's the kind of like a rough walkthrough of all the programs that I was trying to go through. So let me actually. So one thing I'm curious to hear is, where are the yeah. So where are you? Where are you feeling this pain? Like, what is that your team is spending the biggest amount of time in these different parts? So I put the poll up there. I'd love to hear different people's opinion about that. But I guess the thing I wanted to show is, the automating talk about is that automating tests are hard on its own, but having those tests is just a beating. There's then all the work happens for humans, and that's often the pretty expensive part. So I think there's a lot of opportunities to make this more efficient. I'm mainly talking about what's being done by different people through the tools, through the processes, and whatnot. But I'm also looking at the additional tool help that's assisted by the AI and machine learning and more like a data-driven statistical approaches. So I'm interested in talking to people who have these challenges. I'd love to hear where your challenges are so that we can better build the product that addresses this need in the real world. So if you feel like, okay, this is one of the challenges that I have, then I'd love to hear that. And then you can let us know your email address from this URL. It's the QR code. It's the same form. And I'd love to continue the conversations. And if not, I'm happy to take more questions if you have any. All right. Let's see. I think so. Looks like I answered all the questions that a few have already answered along the way. Okay. I'll give it a few more seconds. You should be able to use the Q&A. I think it should be a button on your screen for you to type this up. All right. Well, if not, then I guess you all have a wonderful day, and thanks for being here. Let's see. So I guess the one question actually came in. So what is asking? Can I please repeat what I mentioned about connect the dots between build, commit number, and issue? Right. I guess so. He's probably talking about here. Yeah. So if the software that you built, the binary you built, had the commit that I guess the commit hash of the source code used to build that product, build that binary, then that's the one link. And then if you have from that commit, you could see if you can look at the commit graph. So if you can run the git log and see all the ticket references, then you can see that, oh, these changes were designed to fix this problem or implement that enhancement. Then that gives you another link for the traceability. So those are the two links that I was saying that by connecting those two links, connecting those two dots, you get to see in this round of testing, these changes are net new. That includes fix to these issues that we reported earlier on. That becomes unambiguous, automatable, traceable thing. That's what I was trying to say. All right. Okay. So I think that's it really for this time. So thank you very much, and have a wonderful day. And I'm looking forward to hearing back from you. Bye.